So if you're walking through the slides, you know that one of the first slides says that we are going to be acting as a somatic cell, and we're going to experience the cell cycle through this simulation. In order for a cell cycle to start, a cell next to you has to have died, and we're going to get that external growth signal that's going to be sent to our cell. That's going to tell us it's time for us to start the replication process, cellular division, multiplication, whatever you want to call it. This is the only time that multiplication and division mean the same thing. If you look at your slide, you're going to see we are now in the G0 resting phase, and we're moving into G1, which is the very first growth phase. And what we're going to do is we're going to find out what the mass of our cell is, and that is on our bag. The mass of this particular cell is 60 micrometers. So since it is 60 micrometers, what we need to do is we need to figure out how many beans are going to represent the 60 micrometers. And I just have some basic dried beans here. If it's 60 micrometers and each bean represents 5 micrometers, and that means, of course, some basic math, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, so of course that leaves us with the 12 beans, but we have to double our mass in order to be able to replicate. So those 12 beans need to double into 24. 2, 4, 6, 8, 10, 12 more. And so if we were going to use the beans to represent the mass of our cell, this cell would be represented by 24 beans. Okay? So what we're going to do is answer question number 1 on the lab sheet at this point in time. And you will see if you opened up the lab sheet that's in at the bottom of this assignment, that's where all those lab questions are. So you can actually pause the video right now if you're ready, and you can answer question 1. So our mass, the growth of our cell, has to have a checkpoint, and we have a very special protein that comes in, Ras cyclin, and this is our checkpoint. The Ras cyclin regulates the cell's growth, and so for this particular checkpoint, what you're going to do is we're finding this card, and we're going to verify that we have used the correct number of beans to represent the mass of our cell doubled. 60 micrometers is what our mass was. And of course, to show our mass doubled, that should have been represented by 24 beans, which we did correctly. So our checkpoint with Ras cyclin was good, which means our cell can continue through that process. If it would have been incorrect, then the cell would have had to go back through the growth phase and fixed any errors, or the cell would have gone through what we call apoptosis, which is when the cell triggers its own death.